Hello everybody, welcome to today's RadarShark video. Now today is a very unexpected and very shocking video. The most recent EF5 in literally 13 years was upgraded to an EF5. Well, no, an EF5 was not upgraded to an EF5. An EF3 was upgraded to an EF5 that happened in June. On June 20th of this year to be exact, which is insane because that means that is officially the end of the EF5 drought. For those who don't know, the EF5 drought is something that has been occurring with the National Weather Service since 2013. In 2013, as most of y'all watching this video will likely know, Moore was hit by an EF5 in 2013, and after that, there were just no EF5 tornadoes. Even El Reno, that was not rated EF5, but that drought ends today. We are going to talk about an EF5 that happened in June in North Dakota near Enderlin. We're going to look at the path, we're going to look at the damage, and we're even going to look at what caused this tornado to have such extreme winds and strength. Let's get right into it. Alright, as y'all can see here, I'm sorry if, I don't know if y'all can see this, but the screen is being a little glitchy. I don't know if y'all can actually see that, and I'm sorry about that. I think it's just an issue. I need to just restart my computer for that to work. But, I mean, I've already refilmed this video at least, like, 2 times. And I don't really want to do it again. So, here's the town of Enderlin. Actually a fairly small town. And this is a railroad right here. And the damage that, and what gave this tornado its EF5 rating, actually some train cars that were hit, and there was one train car full of grain, which is really heavy, needs winds of well over 200 miles an hour, like lift it up off the ground. It lifted it up. It lifted up one of the train cars and carried it 500 feet, or nearly 500 feet, and it's just kind of sitting there in the field. So where this triangle is, that is where that train car is. It just sat there. It just sat there for like, who knows how long. I don't even know how long it took them to clean up. I don't even know when they cleaned up. As you can see though, there were a few other tornadoes around this EF5, which this was, I mean, I guess this was just a crazy tornado outbreak. You can see that there were deviant tornadoes, very, very deviant tornadoes. It's just like Spiritwood, literally, it was literally like it's like mac and cheese. EF3 just curved in a backwards C. You can see there was an EFU tornado right there, which is pretty crazy. And then there's an EF2, like an EF1 up there, EF0, 2 EF1. It's like, this is a large tornado outbreak. Look at this tornado. Very deviant. Whoop. Like a banana. So that seemed to kind of be the theme of this tornado outbreak. Deviant, but kind of strong tornadoes. You can actually see how a lot of tornadoes that are strong, they curved northward really quick, then died out, which is a strange occurrence which happened with a lot of these. So let's go ahead and take a look at the tornado path itself. As you can see, path, it looks almost identical to Greensburg. I'll put up an image of Greensburg damage path, not damage path, like, yes, damage path, on screen right now. You can see just how freaking similar they are. Crazy similar. And let's take a look at the damage that this that this tornado actually caused to get its rating. Alright, this picture is taken by Aaron Rigsby. Now you can see, I actually didn't notice this at first, but you can see, well, actually the rails here have been almost sanded down, which is interesting, or that's maybe just a pile of dirt. But you can see there's some train cars that are like kind of rolled over there. You can see some ground scouring, and you can see like these train cars that are like right there, but you can see that one over there. Now, these things are really big. Like, I bet if LeBron James were to stand next to that, he'd probably only cover like a fourth of the height. They are really big. One thing you can notice too are these giant dumbbell looking things. Now those are not dumbbells, those are train wheels which seem to have been ripped off. Well, not seem to have, you can obviously you can see that they've been ripped off, but the winds were so ferocious that I think like the cars themselves were ripped off the wheels, or they were snapped off the wheels before even like going airborne, which is just insane because you can see they're scattered everywhere. You can see more. There's like here, here, here. There's some here, like in the grass, and you can actually see it like there's like I don't know, like the field is like all brown now. And you can see there's like dead trees back there in the background. Apparently, those trees were freaking sandpapered, which the sandpapering effect with tornadoes is basically when they have so much dirt and sand, like little rocks in them, and like when it hits stuff, it like wears it down, makes it all smooth, just like sandpaper. So let's go ahead and take a look at the conditions that actually caused this intense, very intense tornado outbreak to happen, and what actually caused this tornado to, form and sustain itself. All right, so here we are looking at the HREF. It basically takes CAMs or convective allowing models and kind of makes it into one kind of thing. So this is the 20th, which is basically that's the day of the outbreak. So you can see there's like about in North Dakota you can see there's about like this is at 500 millibars, so kind of high up in the atmosphere. You can see that winds are kind of ripping at like 50, almost 50 miles an hour. As we go late into the afternoon, you can see it's still like at like 45, 50 miles an hour, which is really like that's really like, even though the colors may look like not intimidating, like 35 knots of winds like that, they can produce tornadoes. So let's take a look at some upper or some lower levels and see if we can find some wind shear. As you can see, as we go into later in the day, you can see there's a much larger area which of darker color, which is called the low level jet. So this must have been the low level jet just kicking in, and this is early Saturday morning after the event. But you can see there's like, even though the colors may not look intimidating, there is the shear there, and you can see the defluence right here, right over the Fargo. Still, you can still see the like the shear. It's there. I mean, it was definitely there. Let's take a look at 500 millibars again. Yeah. Oh yeah. You can see the wind shear is there. It's there. Like this. I think this is about the time. This is about the time the tornado occurred. You can see the wind shear down in that area that's pretty crazy. You can see the defluence here. That would lead to good rising motion. So let's take a look at some other things. I think we actually have a okay, this was the risk. Here's the tornado risk for that day. A 10% hatch risk. A conditional risk, and that's kind of what I thought is a conditional risk, but if one supercell were to get going, then violent tornadoes will definitely be on the table. So let's go ahead and take a look at some other things. Alright, now this funky little model here, this is called surface relative helicity, or storm relative helicity, I mean. And basically what this means is spinning updrafts, and that pink, ooh, those pinks and purples, that means there's like could be a lot of spin. You may get these like really high numbers, but never see like a tornado risk in that area. It's just because they're lacking the other things needed for it. But as you can see, as we go late into the night, you can see just around that Enderlin area, you can see storm relative helicity just blast off. Like that's pretty high. And since there was like only two supercells, they weren't really choking each other out. So they both the Spiritwood tornado and the Enderlin EF5, they could both get going. They really took advantage of that atmosphere. Now let's take a look at updraft helicity, which basically shows spinning updrafts, but like kind of like in like a little painting. Now I think that since this is a model, sometimes it can be a little bit like weird. But I mean, yeah, you can see that like in that area, you can see that's where that 10% hatched risk was. So you can see it was It was pretty insane. I mean, there was lots of spin in the atmosphere. Definitely things that it needed, or else this tornado would not have happened. All right, now this is called significant tornado parameter. And so if we go later into the day, you can see. Wait, hold on. That's actually a lot. That's a lot more than I thought. You can see that SCP. It just kind of skyrockets there. You can see that near the Enderlin area, you can see it just absolutely skyrockets. Really late into the night. And I think that's one thing that made this tornado kind of deadly is that it was at nighttime. It happened at like 11 p.m. I don't know. It was dark outside. Can't really see it. Okay, now what we have here is dew points. And so the blues and purples generally just high moisture, very moist air. Like higher dew points equals moisture air. So let's take a look here. See, we go late into the night, you see we get a dew point of like 70 degrees up near Enderlin, maybe even 70, like 73, 74 degrees near Enderlin, that's just crazy because that is crazy moist air. And if we look at the temperature and it's close to the dew point, that means it was super high, really high moisture. So let's take a look here. So the oranges is like the 70s. You can see the temperature is about almost 80, but like with a dew point of like almost 75. That is really close. So that's some seriously moist air. That's just, I mean, it's pretty crazy. All right, now let's go ahead and take a look at the damage it caused on Google Maps. Now I gotta wrap this video up real quick, so this won't be too long. All right, so here we are near Enderlin, North Dakota. You can see there it is right there. There's the airport. They have an airport. And you can see there's this kind of line of brown. You're probably wondering what that is. Well, that's the tornado. But one thing that's strange to me is how it's all nice and paved. Not paved. It's all nice and tilled up after the tornado happened. There's not really any crazy ground scouring. It must have been like a quick like kind of thing, and not a. It's very strange. Very strange. That might be something right there. Very strange how there's almost no crazy obvious ground scaring with it. Very interesting. But here's where the train was hit. Now that train is not the train that was hit because it gets on the other track. But right around there, that's where it happened. You can kind of see the dirt matches up. Let's go back to the damage assessment toolkit, and here you can see that dirt kind of it lines up. It lines up like really well. So as you can see, that is it's definitely where the tornado hit. You can see there's definitely some like kind of weird dirt stuff. It may just be like piles of sand. I don't know, but you can see what is that? I think it's like some trees that were just absolutely shredded. You can see there's some trees over here that don't seem like they're doing too well. Property. Oh, holy crap! I did not see this originally. So that's leveled trees, and a house that is pretty much completely not pretty. It's completely destroyed. It's like completely destroyed. What is this? Yeah, you can see there's more trees down here. They're debarked. They're literally debarked. That's pretty wild. I think this tornado will be talked about for years to come. Alright everyone, I hope you enjoyed this video, and I hope you learned something too, because this was a very interesting tornado event. It'll likely be talked about for many years to come. Please subscribe, actually. If you actually made it this far, please subscribe. I work really hard to make these videos. And I just love if y'all could, subscribe, because I'm trying to grow the channel. Trying to, show more people the weather things. And I'll see you on the next video. Bye-bye.